Okay, we're looking at some of the solutions for lesson 6, which is slope, rate of change, and kind of starting our hand at some equations. So for each graph, we need to determine the rise and run between the pairs, so calculate our slope. So we know that slope is just our rise over run. So our rise between this point and this point, what is our rise here? We're from -1 to 4, so we jumped up 5 blocks. So we're going to have our slope here. Our rise is 5. What is our run? We went over 1, 2, 3, 4, 5. So 5 divided by 5, our slope is 1 for the first one. For the second one, we're going to take a look, oh my goodness, all the way up here. I think I can count that high. And then we're going to go over for our run. Okay, excellent. So the second one, our slope is going to be equal to our rise over run. So our rise starts from -7 all the way up to, so if we count that, that should give us 15 squares. And our run goes from -4 to 6, which is 10. So our run is going to count up to 10 squares, and that gives us a slope of 1.5. Next, for each linear relation, create a table of values. So table of values. So here, our table of values, and it says for 0, so this is our x, 0, 1, 2, 3, and here's our 1. So how do you do this? Well, all we need to do is take a look at our formula, y equals 2x plus 5, and what we're going to do is we're going to use our calculator, and we're just going to plug that number right in there in our calculator. So we're going to literally put in our calculator 2 times, and then whatever number we pick. So we're going to start with 2 times 0 plus 5, 2 times 1 plus 5, 2 times 2 plus 5, and then we're going to figure out what it gives us. So when you do your calculator, 2 times 0 plus 5 gives you 5, 2 times 1 plus 5 gives you 7, 2 times 2 plus 5 gives you 9, and 2 times 3 plus 5 gives you 11. Okay, rate of change, what do you do there? You take your second y value and you subtract your first y value. So this is going to be 7 minus 5, gives us a rate of change of 2. Next we're going to do 9 minus 7, that gives us a rate of change of 2. And this one's 11 minus 9, that also gives us a range of 2. Perfect. For the next one, we have same kind of idea. We're going to do a same table of values, x, y, 0, 1, 2, 3. And now we're going to be plugging into this formula, y equals 4x minus 2. So 4 times 0 minus 2, if you do it on your calculator, is going to give you -2. This one's going to give you +2. 2 times 4 minus 2 is going to give you 6, and this one's going to give you 10. So then if we look at our rate of change, 2 times -2 actually gives you 4. 6 minus 2 gives you 4. 10 minus 6 gives you 4. Downtown parking garage charges $2.50 per hour after 6 o'clock. Create a table of values that shows the charges for up to 5 hours of parking. So $2.50 per hour after 6. So let's assume that's what we are talking about here. You know what, guys? I'm going to scrap this question. So number 5, a little ambiguous to me. Not a fan. So 5 is going to be removed from this. Please do not do 5. Number 6, for each linear relation, create a table of values, and then we want to graph it. Oh boy, so let's get into the graphing. So we have our table of values, 0, 1, 2, 3. And y, we have y equals x minus 2. So if I plug that in, y equals x minus 2, y equals 0 minus 2, that's -2. Y equals 1 minus 2, that's -1. Y equals 2 minus 2, that's 0. Y equals 3 minus 2, that is 1. So now if we want it to graph this thing, I'll just back out and just hit some graph paper. And I need to see my numbers. So, okay. So when we looked at it, we found that if this is our quadrant here, we said when our x value was 0, we started off at -2. And when our x value was 1, we found it to be here, here, and here. And this would keep going up and up and up in a very, very straight line. So that's what your graph should look like for the first one here. And as we go to the second one, so here we're going to do another table of values with 0, 1, 2, 3. 3x plus 1, so 3 times 0 plus 1 is 3. 3 times 1 plus 1 is 4. 3 times 2 plus 1 is 7. 3 times 3 plus 1 is 10. Okay, perfect. And then we want to graph this thing. So I'm going to just do a little mini graph, actually right here. Okay, so when x is 0, y is 1, so that's our first point. When x is 1, y is 4. When x is 2, y is 7. And when x is 3, y is 10. So it should be a pretty steep line, something like that. Okay, excellent. Number 8, we have to do all this. Okay. Determine the rate of change in BIM's earnings for each basket he picked. So what is our rate of change? So when we're looking at rate of change, we need to examine what is the difference between this and that. So 3 minus 150, it's 1.5. 4.5 minus 3, 1.5. 6 minus 4.5, 1.5. 5 minus 6 is 1.5, and 6 minus 5 is 1.5. So our rate of change is consistent. So now we want to actually try to graph this data. So here we're actually going to make a little bit more of a proper graph just to demonstrate a concept. So here we have that. And then on here we're going to have our earnings. And let's just open this up. Okay, so it starts off at 1.5, 3, 4.5, 6, 7.5, 9, perfect. So when BIM picked 1 basket, 2 baskets, 3 baskets, 4 baskets, 5 baskets, okay. So at 1 basket earned 1.5, 2 baskets earned 3, 3 baskets earned 4.5, and so on and so forth. You'll see that this makes a very nice and straight line indeed. Beautiful. So determine the slope of the line. We can determine the slope of the line very easily because we can pick any 2 points on this line that our heart desires. So I'm just going to pick this one. Sure, let's pick this. And I will pick this. I'm going to pick these 2 things. So what is our rise? Well, our rise here, we went from 3 to 6, so we went up 3. And what is our run? We went over 2. So if we look at rise over run, we have 3 divided by 2, which is 1.5. And that's a familiar number because if we backpedal, look at our rate of change. It's also 1.5. So the slope of the line we figured out was 1.5. How does the slope relate? They are equal to each other. Okay, 10. The profile of a ramp is shown below. Determine the rise and run. And we want to calculate the slope. So what is our rise and run? Well, here we only went up 1. And we went over, this whole distance here was 10. So rise over run is our slope. So it's going to be 1 divided by 10, which gives us a slope of 0.1. Okay, now we're looking at slope. Which side of this roof has a positive slope? Which side has a negative slope? Positive slope rises. So this thing is rising. This would be our positive side. This thing is going down like negative slopes do. These things drop. So this would be our negative side. State whether each slope, the slope of each line is positive, negative, or 0. So we are just going to be looking at what we call our M value, which is what is connected, or our coefficient, to the x. So all we care about is this. So we can actually go through and circle what's ever connected to our x to make this a whole lot easier. So here we have -1. So I've gone through and I've circled everything that's connected to our x. And now, if the number is positive, our slope is positive. So for A, positive number, it's positive. B, or C, it's a negative number. This is going to be negative. E, we have a positive number. It's positive. And then here, we don't have a number next to our x. That means our slope is going to be 0. It's just going to be a flat line. Here it's negative, so we have negative. Here it doesn't have anything. It's a 0. Here it's negative, so it's negative. And here it's positive, so we have a positive slope. And it's literally that easy. Make sure if you didn't get that, slow me down, back me up, and do it again. All right, are they parallel? This means we need the exact same slope. So do they have the same slope, the same M value that we just talked about? So here, 3 and -3, no. Those are not the same. Here we have an x and an x. They both have a 1 in front of them. Yep, those are parallel. Here we have -2, -2. Yep, that looks good. 1/2 and 0.5, those are the same number, even though one's a fraction. Quarter and a quarter, yep. Here, good question. 4 and 0, what's the slope of these lines? Remember, if we just back this thing up, we said the slope, if they don't have an x, is 0. So this thing has a slope of 0. This thing has a slope of 0. These things are also parallel. 0.08 and 0.8 are not the same thing. And here we have 90x and 100x. Those are not the same thing, so they're not parallel. Write the equation of a line that is parallel to each line. Well, this is nice and easy for us. We can literally just pick any number to change here. So for A, if we're looking at A, we just need y equals negative 4 over 3x. That has to be the same. If we want a parallel line, remember, the only thing that has to happen is our slope needs to be the same. The rest, we can make this minus 100 and it would still be parallel. Okay, and then I believe we also need to take a look at B, C, and D. Okay, so for B, we're going to take y equals, and now we have 0.9x. That has to stay the same. And then this plus 6, we can change to anything. We can make it plus 50 if we wanted, and that would be fine. For C, what is the slope of this line? It doesn't have an x value there. We know the slope is 0. So we can just say y equals, and we can pick any number we want. Y equals 4, y equals 5, y equals 6. Doesn't matter. This one, y equals, and what is our slope here? It's a negative x. So let's keep it as a negative x, and then we can change this. We can change this value right here. So instead of plus 1, we can make it minus 4, and it would be fine. Okay, for part C, we need to find some equations for each graph. We're going to determine the slope and y-intercept, then write that equation. Okay, so let's determine our slope and y-intercept. So very first thing we can do, so let's look at 1A, I guess, to start off. What is our slope? I'm going to use red. So let's look at this point and this point. So here our slope is our rise over our run. Our run is 2. Our rise is 1, 5, so it's 4. So if we take 4 divided by 2, our slope is going to be 2. So we know our m value is 2. Now the other thing is our y-intercept. Remember, this is equal to our b. And we can look at this right on a graph. Look, it's right here. It's where our line crosses our y-axis. So where does it cross it? Well, it crosses it right at the number 1. So our b is 1. So if we look at this formula, y equals mx plus b, well, we have some values. So y equals m, which is 2x, plus b, which is 1. So here's the equation of our line for the first one. For our next one, we can use this point and we can use this point. Perfect. Rise over run. So we're going to take a look here. What's our rise? Well, we went down 3, so negative 3, and we went over 3. Perfect. So our rise over run. M equals our rise, negative 3, divided by our run, which is 3, so our m is going to be equal to negative 1. What is our y-intercept? That's this point here. Where does it cross the axis? It crosses at negative 3. So y equals m, which is negative 1, x minus 3, and you should be looking at this saying, this looks kind of weird. Yeah, because we don't like writing those things like that. We'd rather clean that up and say y equals negative x minus 3. Remember, we don't want to write that 1 if we don't have to. Okay. If we look at C, here's one point, here's another point. Our run, here's our rise. So we're going up from 4 to 7. That gives us a rise of 3. Our run, if we count it, we're going from 0 all the way to 4. So our run is 4. So our m value is going to be equal to our rise, which is 3, divided by our run, which is 4. Perfect. And that equals 0.75. Our b value, which is our y-intercept, where does it cross it? Well, it crosses it right at 4. So our formula is going to be y equals 0.75x plus 4. Okay, and the last one here, we go from here to here. So our rise, we are dropping from 1 all the way to 4. That's a drop of 5. So we went negative 5, and we went over 1, 2, 3. Perfect. So our m value here is going to be our rise, negative 5, divided by our run, which is 3. We could just leave that as a fraction if we'd like. Our b value, it looks like it crosses it, maybe like right about there, maybe like negative 2.5. So let's put that in. I might be a little off, and that's okay, but that looks like a good b value to me. So when we come up with our formula, y equals negative 5 over 3x minus 2.5. Perfect. So given each slope and y-intercept, write the equation of the line. Then we want to graph it. So I'll graph the first one. After that, it'll be up to you to graph that. Actually, I'll graph A and I'll graph D for you. Okay, first one says it has a slope of 1 and a y-intercept of 1. So for A, y equals a slope of 1. So we have 1x, and our y-intercept, which is our b value, is minus 1. Remember, we're always putting these in the formula. Y equals mx plus b. Our slope is our m. This is our b. Okay? For b, y equals 3x plus 8. For c, y equals negative 2 over 3x, and then our y-intercept is 0. We don't need to write it. For d, it'd be y equals 0x minus 2. We don't want to write 0x. We can just write y equals minus 2. So to graph these things, I will graph A and I will graph D. So if this is that, y equals x minus 1, so we know we're going to start our graph. One point is going to be at minus 1. This is our y-intercept for A. So here's where our graph starts. Now our slope is 1x, which is positive. So that means our rise, every time we go up 1, we need to go over 1. So we go up 1, we go over 1, and we find this point here. We go up 1, we go over 1, because our rise or our slope is 1. So let's double check. Our rise over run, 1, 1. Looks good to me. 1 divided by 1 is going to give us 1. For B, so let's say we're going up by 2s, 2, 4, 6, 8. Excellent. Actually, I'm going to go up by 4s because this graph's going to be pretty big. 4, 8, 12, 16. Lovely. So our y-intercept here is 8, and our slope is 3. So what that means is we need to go up 3 and over 1, right? Because our slope is 3, which means our rise is 3, our run is 1. So every time we go up 3, we're going to go over 1. So we're going to go up 3 over 1. Go up 3 over 1. And we're going to get a nice straight line here. Perfect. Okay. For C, y equals negative 2 over 3x. This one starts directly at 0 because we do not have a y-intercept defined, which means we start at 0. And this says we're going to go down 2, so we're going to go down 2, and we're going to go over 3. 1, 2, 3. So this is going to be our next point. Connect those two things up. Oh, what an ugly, I can't even justify that line. That's better. And that will be our graph there. And then for D, which just says y equals negative 2. Well, the only thing they gave us is a y-intercept, which is this, at negative 2. And then we don't have a slope. If we don't have a slope, it means it's a flat line. So here's our line. And that is that complete.